Hello friends, uh, I welcome you all in B.Sc third year. I will be taking your paper number 13A, that is solid state physics, right. So, as like every paper, this paper also contains 4 unit. You can see on the screen, these are the 4 different unit. Unit first is crystal structure, unit second is bonding in solids and X-ray diffraction, unit third is thermal properties of solids, and unit fourth one is free electron theory of metals. So, in today's video we will just talk about the syllabus, what exactly we have to learn in this particular paper, that is solid state physics. What are the different articles, different concept as per the syllabus of our university we have to learn in this particular paper, that we will see in today's video, and from the next video onwards we will see in detail concept by concept syllabus. Okay. Now, the first unit, that is what the crystal structure. So, as the paper name, that is solid state physics. So, first thing we have to keep in mind, whatever we have to see, that is completely restricted to the solid in this particular paper. Everything we are talking about solids, not about the gases or not about the liquids. So, maybe these properties are different for gases or for the liquid, but here we have to just concentrate our mind on solids. So, the first unit is crystal structure. So, every solid is made up of some atoms, then molecules, and then that solid generates, and then all the particular atoms are bonded together and they form molecule, then molecule forms substance, and then different substances forms different materials, what we call the solid materials basically, right. Now, first unit is what a crystal structure, right. Now, we have some naturally occurring materials which are called as crystals, or some artificial crystals are also there. But what exactly the crystal means? Crystal means what? If we have a material and that material contains a regular or periodic arrangement of atoms, that means what? If a material is there and all the atoms, yes, we know the material or the any substance contains basic thing, that is what? Atoms. Yes, obviously if we go again deeper into the atom, nucleus and then core, but that is not our interest in this particular syllabus. Here, yes, we will restrict ourselves up to the atoms. So, if we talk about the atoms, so how will be the arrangement of atoms within that particular material, that particularly describes or that particularly decides whether it is a crystalline material, and the other category is the amorphous material. Means what? The opposite word to the crystal is amorphous, or crystalline structure and amorphous structure. So, amorphous means what? The atoms are irregularly arranged in that particular material. But when we say about the crystal, so crystal means all the atoms are periodically arranged. Periodically arranged means what? They have a specific spacing, or they have a fixed spacing. When we talk about any particular atom, then that atom is located at a specific distance, periodic distance from every other atom. That is what we call the periodic arrangement, or every neighboring atom is at a equal distance from the previous atom. That is what we call specific distance or specific periodic arrangement, right. Now, in this particular unit, what exactly we have to see? Yes, you can see on the screen. So, what are the different articles in this particular first unit, crystal structure? So, firstly we will just introduce whatever I have just talked about within 2 minutes, what is crystal and all these things, crystal theory or everything we will see in the introduction part. Next one is crystal lattices and translational vector. Okay, so the lattice means what? Where the locations of atoms. Lattice means what? We have something which we can, or we can say it is a frame like structure, where if we keep the atoms, then that atoms keeping, that we call the basis. Okay, so basically crystal, if we have to define crystal mathematically, that is crystal is equal to lattice plus basis. That we will see in detail when we talk about that particular article, but for a while you can remember the lattice and basis combinedly forms the crystal. So, the lattice means what? It is simply a framework or simply a frame. On that frame, if we put the basis, then that forms the crystal. So, the crystal lattices. So, depends upon the lattices, we have different types of crystals. If we use the different crystal, means atoms are same, but if we use the different lattice, then that crystal structure will be different. Okay. Now, the next one is what? Translational vector. Translational vector. Translations vector means what? How to translate that particular crystal. That means what? If I have a crystal and I am seeing that crystal from front side, I am seeing that crystal from top side, or someone is seeing that crystal into the mirror. So these are what different translations. Or if I am seeing the crystal at x is equal to 0 position and somebody has shifted after some time x is equal to 5 centimeter, then whether will be or whether it will be some changes in the properties or some orientations or something, whatever may be, if there are some changes in the crystal, then that depends upon that translational vectors. Next one is unit cell. Unit cell, so basically unit cell means the smallest part of the crystal or smallest part of our crystal structure, and if we repeat that unit cell, whatever may be the structure, it will form, it is as a crystal. That means if we go to the crystal, so crystal is made up of different unit cells. Basically we can say in simple language, crystal is made up of different unit cell, or if we talk about the definition, then it is a repetitive unit. We can say the repetitive part of a crystal which when we repeat, crystal forms. That is what we call unit cell. Okay, unit means a single cell, or we can call it as a minimum cell again. So basically what next one is what? Basis. So just I told about the basis, lattice and basis forms the crystal. Next article is symmetry operations. Symmetry operations means again, if we have different 4 types of symmetries, again there are translational symmetry, rotational symmetry. So means what? If I have observed the crystal and if I rotate it by 90 degree or by some angle, and then what happens to that crystal, whether some or where some property changes or whether it will remain constant, whatever may be, that are our symmetry operations. Next one are the point groups and space groups. So depends upon these different types of, we have different 2-dimensional lattices as well as 3-dimensional lattices, and depends upon their combinations with the basis, we have some specific 2-dimensional point groups and 3-dimensional point groups. Similarly space groups also there. Next one, so in this particular video we will just talk about what syllabus we have to see, one by one article we will explain very deeply. Now next one is the types of lattices. Just I told you the lattices are not of a single type, we have different types of lattices. Again their major category 2-dimensional and 3-dimensional, and again in 3-dimensional and 2-dimensional we have several subcategories of the lattices. Then few they have mentioned in the syllabus itself only. Simple crystal, in bracket you can see HCP means hexagonal closed pack, FCC that means face centered cubic, BCC that is body centered cubic, SC that is simple cubic, right? So these are some cubic structure category, but we have some polygon, then hexagonal, then tetragonal. So these are different types. So we will see one by one detail in next videos. Next one is what? Structure of diamond. So diamond is also a crystal. So how it is, or how will be the structure of diamond, internal structure of diamond, or basically atomic structure, right? How atoms are arranged into the diamond, that we have to see. Next one is NaCl, that is what our salt. So that NaCl is also a crystal, and how are the arrangement of Na atoms and Cl atoms in that particular structure, that we have to see, and we will solve some basic problems on the basis of our crystal structure theory. Okay, so this is what we have to see in unit first, crystal structure. So next unit is, next unit is bonding in solids and X-ray diffraction, right? So you can see on the screen unit second, bonding in solid and X-ray diffraction, and what are the contents in that particular unit. First one is or the name itself indicates for that particular unit, bonding in solids. So what we have seen in the first unit, only the crystal structure, how are the different crystal structure, but how those crystals are formed. So initially I told you every atom is bonded with the other atom with the help of some bond. So again the bond are of not single category, we have different types of bonds, and depends upon the environment around that particular atom, depends upon the nature of atom, depends upon again some different factors, we have different bonds. So that we have to see, and then X-ray diffraction, that again we have to see. So the first article in this unit is interatomic forces and types of bonding. So when we say the every atom is bonded with other atom, so it is not like that there is a physical rod between two atoms, right? Or there is nothing like string between two atoms. So why they are bonded? They have some interatomic forces, or they have some attractive or repulsive forces, but they are between the two atoms. That's why we call it as interatomic forces. Okay, so we have to see which are the different interatomic forces which are necessary, or which are the cause to have the bonding between different atoms, and then types of bonding. So depends upon that interatomic forces only we have different kinds of bonds. So which are those? Yes, they have mentioned in the syllabus only. We have ionic bond, covalent bond, metallic bond, hydrogen bond, Vander-Waals bond. These are the different bonds. So this is related to the bonding in solids we have to see in this particular syllabus. So interatomic forces, the forces which are necessary for the bonding, and these are the different 5 types of bonding we have to see. Next one is X-ray diffraction. X-ray diffraction means, so now what in first unit we just categorize the solids, crystalline, amorphous, or specifically crystalline. Next we have seen how these solids are bonded, then that is what by the bonding. But yes, we have to see, or so one may can ask the question, how you can say yes this atom is at 1 centimeter or 1 nanometer from this atom. So this is what that means, we must have some structure of that particular thing physically. We can say yes, this is a crystalline material, this is a amorphous material, because these atoms are not regularly placed from one another. So that is what in short we can say, we must have some scanning system for the metals or solids, so that we can have look how the atoms are arranged into the material, and from that we can conclude whether it is a crystalline material or amorphous material, and that method is called as X-ray diffraction. That or it is or in our simple language, if we have some broken bones in our body, we can go to the lab and we take the X-ray, and that will give you, yes, at this point your bone is broken and something is there. So that means what? Yes, that in the same analogy is here. We have to take the X-ray of material only to have the positions of atoms within the material, and that method is X-ray diffraction method. So the name X-ray, yes, you are using, and next word is diffraction. So why this X-ray diffraction is only useful for this? We have again different methods, but this is most commonly used method. Okay, we will see in detail why the diffraction, X-ray diffraction method is used. Next one is Bragg's law. So this Bragg's law is only utilized in X-ray diffraction method, or on the basis of Bragg's law only we have developed, or the scientists have developed X-ray diffraction method. Again, just I told we have different another methods. The next one is Laue's method, then rotating crystal method. So basically these all methods are to have the scanning of material to specify or to understand the arrangement of atoms within that particular material. This is what the second unit, bonding in solids and X-ray diffraction. Now the third unit is thermal properties of solids. So in the first and second unit we understood what actually the different types of crystals and how they are bonded, and how to identify whether it is a crystalline or amorphous by using different techniques like X-ray diffraction, Laue method, and rotating crystal method. There are again different methods, but these 3 are specifically mentioned in our syllabus. Okay, now next one we have to check the properties of those solid materials. Now we have studied the solid materials internally, we understood the structure. Now we have to check their properties, and more specifically the thermal properties. So therm means heat, yes. So you can directly understood, or we can have guesses that yes, this is what related to the heat. Means we have to expose our solid materials which we have detected, whether it is amorphous or crystalline, or whether it is simple cubic, body centered cubic, face centered cubic, or different categories. Yes, this material we have concluded, yes, this is of this category, but now we have to check its properties, moreover thermal properties. So it means we have to expose that material, to the heat. Yes, right. Now first article in this unit is specific heat of gases. Now you might have the question, sir, you told initially only there is nothing about the gases and liquid in this particular paper, but yes, the first article itself is the specific heat of gases. But why it is? Because we are having analogy of specific heat concept from gases to solids. Yes, because already we have seen this particular gases, we have already seen the specific heat for the gases, and therefore we are using the same analogy for the solids. So we will just define here the specific heat of gases, then by taking the same analogy we will go to the specific heat of solids. So specific heat means we know for the gases or for the solids we have the amount of heat energy required to raise the temperature of that particular material by 1 degree Celsius. As we have defined this, or as we have already seen in case of gases, the same definition will be applicable for the solids, only instead of gases here we are replacing the word solids. Next, classical theory of lattice heat capacity, right? Heat capacity is also what we call the specific heat only, CV, right? Yes, specific heat at a constant volume, C suffix V. So we have to see the classical approach. Yes, means when we took a solid, we have two different things, right? If I look by the naked eyes, that will be the classical approach, but when we go by the X-ray diffraction or Laue method or rotating crystal method, we will have the internal arrangement of atoms of that structure, and that atom are cannot be seen by our naked eyes. That means that will be the quantum approach, we can say that will be the quantum approach. So we have to see both the theories, classical theory as well as Einstein's theory. Einstein's went into the deep and he talked about the quantum mechanics, and then that theory also known as quantum theory or Einstein's theory. Classical theory only talk about the external appearance of the material and how the externally material behaves with respect to the heat. Yes, but yes, external heat does not only changes the color, shape, size of the material, it can changes some internal properties also, it can changes some interatomic distance also. That is what quantum level, and that will be discussed in Einstein's theory of specific heat. Next one is again as like Einstein, Debye has given his own theory. Again it is related to the specific heat. So all these theories are having, see, because of some drawback in the previous theory, there will be some new theory. Yes, Einstein have developed classical theory talks about or classical theory have some limitations, and those limitations are overcome in Einstein's theory. Again Einstein's theory have some limitations, and that limitations are overcome in Debye theory. That's why we have to see all these three theories. And lastly again Debye theory will also have some limitations. So that is what the last article, limitations of Debye model. But most familiar we will have this Debye model only. Okay, this is what the end of this third unit. Now the fourth unit is you can see free electron theory of metals. Now up to this I told you every atom is bonded with the other atom and therefore the solid forms. But yes, there are some free electrons within the atoms, and how those free electrons or the moving electron changes the property of material, or specifically for the metals we will see in this fourth unit, free electron theory of metal. That means that free electron does affects on the internal property or some thermal property or electronic property of the metal, and how it is behaving or how it is changing, that we have to see in this particular unit. Yes, now see the contents of this unit again. First article is the outstanding properties of metal. So when we have to discuss about the metal, we must have knows about its properties, whether it is electrically good conductor or thermally good conductor or bad conductor, everything we have to see. Or again other than this we have to see some outstanding properties of metals, or those properties will it change with respect to the temperature or not, that we will see in the first article. Then we have Drude-Lorentz theory. That theory talks about the electrical and thermal conductivity. Yes, Drude-Lorentz theory talks about the electrical conductivity and thermal conductivity. And the next article itself is the thermal conductivity, means how will it be the ability of that particular material to conduct the therm, that means to conduct the heat, that is thermal conductivity. Electrical conductivity we know, yes, electrical conductivity means how is the ability of that particular material to conduct the electricity, that is electrical conductivity. Here not only we have to see about the definition, but actual derivation, formula for the thermal conductivity of metal, electrical conductivity of metal. Then Wiedemann-Franz relation. That Wiedemann-Franz relation is a small article, but it will take the help of the formula of electrical conductivity and thermal conductivity. From that it will be derived. What is that? Wiedemann-Franz relation. Next one is Sommerfeld model. That model will also talk about the free electron theory, how the electron, or moreover they have seen quantum mechanical approach, how the electron has been treated as a quantum particle. We not have to see only about the external appearance, but due to the motion of this free electron, what exactly changes happens, that has been studied by the Sommerfeld. We will see that Sommerfeld model. In that we have to take the example help of quantum mechanics, that is the wave function, and we have to find some energy, momentum, all these things. Okay. Next one is the electrical conductivity and Ohm's law. That we have here in this article we have to see, is there any relation between electrical conductivity and Ohm's law, and that we have to derive mathematically. Next one is electronic specific heat. Okay, so as we have seen the specific heat in gases, specific heat of the solids. So is there any electronic specific heat, and how it is, and how to derive it, or how to get its formula, that we will see in this article. Next one is thermionic emission. So the emission means what? Yes, something is emitting, and thermionic means what? Therm, again it is heat. So if we have some heat treatment to the metal, is there any emission of some ions? That what we have to see in this particular article. And then escape of electron from metal. Yes, emission is different and escape is different. Escape means that electron will be free from the particular material, that is what we call escape of electron from metal. So this is what we have to see in this particular unit. So you can see at one glance on the screen we have 4 different units and their contents also. So their contents you can see up to this or after the particular unit. So this is what paper 13A solid state physics, 4 different units and their contents. So this video ends here only, because this is only made up for the introduction of syllabus. Next on video onwards we will look into the detailed syllabus of this particular paper. Okay, thank you.